Hello and welcome back to this lesson. Here we're going to learn what is a container. And for that I will just go and I will open up a paint because I want you to see some things that I'm going to draw. So okay, first the question is what is a container? And let's get to the basics and let me draw here. Okay, this is ugly. Let me draw an operating system here. Here we have an operating system, right? You all know what an operating system is. It could be Linux or Mac OS or Windows or whatever. The thing is that we're going to be using Linux because most of containers these days are running in Linux. So here we have an OS which is Linux, right? And in this operating system we have a bunch of processes because basically that's the nature of an operating system, to run processes. So inside of this operating system we have some processes that are running here. Say, I don't know, SSH process, user interface processes, web server processes, all of the processes that you need, all of the processes that you want. So now the question is, what is a container? And well, as the word tells you, a container is nothing else but a process which is isolated in something called a namespace. So say that I want to isolate this process from all of this which are in the operating system, and I want to isolate this and I want to control the resources that this container may use. Or I want to have this separated from all of this and I don't want any kind of communication from this process to these other processes. So this is like I'm just putting this container in a sandbox, and a sandbox is like just the notion of isolation. Let's say that I'm isolating this process in a container. So basically I have a container which isolates the process that is running from the other processes. So here we have two important concepts. One for container is, let me draw two lines. So one concept is a namespace, and a namespace is basically the ID or the name of the process of this container. So this will be started in a sandbox, which is a namespace, and that will be like the ID of the process. And secondly, we will have something which is called C groups. And using C groups allows you to limit the CPU, the memory, and a lot of resources, so you can limit your container to do only the things that you want it to do, right? So basically, this is the most fundamental concept or notion of what a container is. And a container is nothing else but a process inside of a sandbox, which is called a container. A container contains a process which runs in a namespace and has C groups to control it. And well, I said that there is only one process here, but typically in Docker you only run one process per container. But of course, if you wanted, you could just go ahead and inside of this container you could create, or you could spin up another process which will live with this process, and these processes will be able to talk to each other because they are in the same container, they are sharing the same namespace, and they are sharing these C groups here. So basically this is, as I told you, the most fundamental notion of a container. It's a container, a sandbox which contains typically one process, it could be more than one, and this inherits a namespace and C groups to control what the container can do. So this is it for this video. I hope that you have now a clearer understanding of what a container is. I'll see you in the next lesson. Hello and welcome back. In this lesson, we're going to learn what is an image. If we take a look at this picture, we already know that this is a container which has two processes on it. Typically, it only has one, but in this case, we just created two. But this process is in a sandbox, which gives it a namespace and some C groups to control it, right? But now the question is, okay, this is a container, but how do I create a container? That's another good question. And then is where the concept of image comes in the way. then you may be wondering, what is an image? We can say that an image is a lot of layers in one whole compacted thing, which has a parent and child relationship. So let me draw some things here. Okay, so here on top of every single image in Docker, we have something called Scratch. So I think that it's better if I just do something like this and I type Scratch. Yes, it's quite better. So we have an image which is called Scratch, and Scratch is basically the base for every image that you are going to build in Docker. So it's like the base, it's like an empty the empty representation for an operating system. It's basically nothing, but it's like the base that you need to use to start building images, right? So you will always have this kind of base. The Scratch image will always be the base. Okay, so now that we have this base, you know that this is empty, so we need to put something on top of this. We need the basics of an operating system, remember? Because in an operating system, we run processes. So we need something which is an operating system. It could be CentOS, Debian, or Red Hat, Ubuntu, Alpine, BusyBugs. Let's say that we're gonna pick up BusyBugs. So I will just put here one line. Let me just grab this, which will represent the relationship, the parent relationship between these guys. Because here we have, this is the parent of this guy, and this just means the line that binds it with the second layer or the second level of hierarchy that we have here. So now let me just change the color here, and I will put another layer in this, which will be, of course, I don't know, BusyBugs or Alpine, whatever you want. Let's say BusyBugs. Let's say CentOS better, right? So on top of this Scratch image, we have now this CentOS image, which is kind of an operating system. It contains all of the libraries that an operating system needs to run processes. And now that we have this layer of operating system, we're going to pick up again this line for relationship, which should be green, I think. We're gonna put this line here, and let's change the color again, and we're going to put another layer on top of this layer. And here, let's say that we put some service, some process which will run in this guy, which could be any process, let's say an Nginx or an Apache process. So let's say Apache on top of this. See, that's pretty cool. As you see here in an image, I'm just gonna put here the name of image because that's very important, image. Basically, we've got our parent-child relationship, which starts from scratch, and then on top of a scratch we put an operating system, and then on top of the operating system we put some processes which will run in this operating system. But if I change or if I modify this layer in here, of course this layer is also going to be modified because this is the parent of everything. But then at the same time, this guy is the child of this, but this guy is the parent of this guy. What happens if, for example, you want to put something in top of the Apache? We're gonna put another relationship here, and we're gonna put another layer to this image, which will be a cache service, for example. And well, this is basically the representation of how an image looks like, how's the skeleton for an image. It starts from scratch, then it gives you the basics for an operating system that you can put on top of that layer some process, and in top of this layer you can put another layer. But keep in mind that this guy is the parent of all of these guys, and this layer is the parent of all of this, and this layer is the parent of all of this. So it's obvious that if I change this layer, all of the child are gonna be modified, and if I change this layer, all of these subsequent layers are gonna be modified. And by talking about this, there comes up a new question, which is, then how do I build an image? And that is what we're going to learn in the next lesson. Hello and welcome back. In this lesson, I just want to show you these images, which are some images that we had pending. And now I think that you are able to understand it. So here we're going to see what's the difference between a container and a virtual machine. And basically, as I told you, A container is a sandbox that contains processes, one process or more than one process. And here in this layer, we've got an infrastructure layer, which could be where your application is deployed. Then we have the operating system that I told you, and we have Docker in the operating system installed. And in Docker, we can create these namespaces, which are called containers, and we can have the application or the processes inside of this container, which was created from an image. So here we will have all of the libraries, we will have here the Nginx, the Apache, all of the services that we need to build the application. So we have here one container A with these processes, a container V, and a container C. So we could have a container using, for example, a web server, a container V with a database, and a container C with, I don't know, a Redis service for caching or for things like that. And as you see, they all are independent. If we wanted to delete them, then we just delete this container and it's gone. We didn't affect the operating system. We didn't install any library on it because everything is contained in the container, because that's the whole notion of a container. It should contain everything. So we shouldn't install anything on the host operating system because everything is going to be contained in the container itself. Now, how is the thing with the virtual machines? Well, it's way different here because we have, again, the same infrastructure. It could be cloud, AWS, on-premise, it doesn't matter. Then we have here an hypervisor, which is kind of a manager for all the virtual machines. And now, in order to accomplish this infrastructure, this tiny infrastructure here, which has a web server, a database, and a Redis service, we would need to spin up 3 virtual machines, and each one of these machines should have a guest operating system. And here we only have one because this is only one machine, but here we have 3 machines. So here, instead of having the container with the web service, we're basically installing the web server in the operating system, and here we have the operating system, but we're just creating a sandbox to isolate the web server process. Same thing here in the virtual machine number 2. We have the second service, which is installed in the operating system, let's say the database. But here we have, in the same machine, we have another sandbox, another container, which contains the database service. So if you see the differences here, the first one is that here we're using a lot of resources because you need at least 1 gig in RAM to spin up this operating system, another gig here, and another gig here. That means 3 gigabytes in RAM. And here probably you will only have 1 gig or 2. And the second thing here is that you are having a lot of resources which are probably not being used. And in this machine, you can easily create containers and you can restrict the resources that they are going to use. But here it comes the coolest thing in Docker compared to virtual machine, and that is, what if you want just to delete everything here and you want to recreate it? What if you want to delete all of your containers? You just go ahead and type Docker, please delete the containers, and all of this is gone, and the operating system is not impacted. But here you have all of the libraries and the dependencies installed on the virtual machine itself. So if you wanted to destroy this, then you would need to destroy the entire virtual machine, or going manually and start deleting or uninstalling all of the dependencies and the libraries that you installed here. So here it would take you like a couple of hours to do it, and here it's just a matter of seconds. So that's why Docker is pretty cool. So this is it for this video. I hope that you have now a clearer understanding on what's the difference between a container and a virtual machine. I'll see you in the next lesson. Hello and welcome back. In this video, we're going to talk about the Docker file. Do you remember the image that we had here? We have here this kind of drawing that shows you how containers are created. Remember that we have an image which contains all of the information, which is kind of a template or a snapshot that will be instantiated as a container. So here we have the image which contains all the information, and then we just create a container or a bunch of containers based on this image, which is kind of a snapshot thing. So now how do we build images? That's the question. And Then here is where the Docker file comes in. A Docker file is nothing else but a plain text file where you define the instructions to create your image. So typically, a Docker file starts with from, which is an instruction that says, okay, I want this guy as an operating system, as the operating system layer. So this instruction could be this one that gives you the binaries that are going to be used as a base for the operating system. About this scratch image, this is important for you to know, but you're not going to be using it because this is a default thing that happens in the background. So you don't really need to care about this. Okay, great. Then second, you have this run instruction, which based on the operating system that you chose, it will give you the ability to install packages. So say that you choose Ubuntu here, then you say apt-get. If you choose a Red Hat based like CentOS, you say yum install whatever. Or if you choose Alpine, then you would say apk add something. But in this case, where we are picking up CentOS, and then we'll run the HTTPD installation, which is the Apache installation. And this could be this layer, which is the layer that sits on top of this CentOS image and installs the application or the libraries that your application needs to run. And finally, well, you could do more things, install more things if you wanted. You could copy things from outside to the image and do everything that your application needs to run. But no worries, this is just a tiny introduction for a Docker file. We will see this in the future, but I want you to see how simple it can be. Right? So here we have the operating system as a base, then we have the libraries that the application needs, and here normally the CMD means the command that will be triggered once the container gets created. So in this case, what we're doing is that we're basically just starting the Apache service in the foreground using this line. So we just say, okay, please start from CentOS, then install these libraries. It could be all the libraries that you want. And finally, please use this command to start the service, because if you install a service, of course you need to start it. You need to start the process. You need to start the Apache process for you to be able to go to the browser and see your website, right? So this is the most basic notion of a Docker file. It's just a text file that allows you to define the instructions that should be run for your image to be created. No worries about the Docker file. We will be talking about this in the future in depth. But for now, I just want you to know how images are created. And they are basically created using the Docker file. So this is it for this video. I'll see you in the next lesson. Hello and welcome back. In this video, we're going to talk about the Docker architecture. We're going to see how Docker is structured. I hope that you are not getting boring because of this much theory, but trust me, it's quite important for you to know this. It's quite important for you to know how a container is created, how the processes are spawned, what is an image, what's a namespace, what's a C group. That's really important for you to know. So let's keep going to this architecture lesson and let's see how Docker works in the Docker host. What is a Docker host? Well, let's say that you have a machine, a virtual machine or a real machine, it doesn't really matter, but say that you want to install Docker in this machine. So once you install Docker on your machine or on your computer or in any server, then automatically that server becomes a Docker host. Why a Docker host? Well, it's because it's hosting a Docker service, a Docker server actually. So your machine that has Docker installed is actually capable to run containers and build images. So that's why we call this a Docker host. So the Docker host is basically the house of all of the containers that you will be creating from now on. Then we have a couple of cool things here, which is this ecosystem that you are seeing here. We have the server, which is the Docker daemon, and that is the process that is started once you install Docker. So when you install Docker, basically you are setting up a server, which is a Docker server, and then you will have a client, and then you will say Docker please create one container. Docker, please remove this container. And that's going to be the client. That's how you interact with the Docker server. But you cannot talk to the server without an API. So basically what you do is that you say, okay, Docker, please run this. And once you say that, then the client is going to talk to the server through an API. So you will be using the client, which is the CLI, to send API requests to the daemon. The daemon will respond you back using the same API to give you an answer. So that's how the client gets communicated with the server, through an API. So remember that at any time that you are typing commands in the command line, you are basically doing API calls to the server, and the server is giving you back a response. So that's great. Now with the client, remember that you will talk to the server, but with the client you can manage containers, you can manage images, you can manage network stuff, and you can manage volumes. We will talk about network and volumes later, but this is the entire world of Docker in the Docker host. This is the entire ecosystem. So basically through the client you will be managing everything. I hope that you have really learned a lot from this, and I'll see you in the next lesson. Hello and welcome back. In this lesson, we're just gonna point out some important things that I really think that you need to know, and that is about images and containers. Remember that these two concepts are way powerful in Docker. An image is a template where you define all of the binaries, all of the libraries that your application will need, and the container is nothing else but the runtime of the image. So you can have one template of as an image, and then you can just create as many containers as you want using that image. But the thing here is that I wanted to show you this. Here we have an image which is composed by layers. Do you remember the from instruction, the run instruction, the cmd instruction? All of those are layers. So this is an image, and here we have an Ubuntu layer, and say that here we are installing SSHD, and here we install Apache, and here we copy files or we do things. But the thing that I want you to know is that these layers are read-only layers. So once you create an image, you cannot modify any layer in that image. Instead, what you can do is that you can just create another image starting from the layer that you want. So for example, say that you have these layers, and let's say that here you have an Apache web server, and here you are copying some, I don't know, some source code. Now say that you want to update the code in this layer because you updated something, right? But remember that the layers in the image are read-only, so you can't update this layer. Then what you can do is that you can just create a new image starting from this layer, which contains the web server, and then you just add a new layer here with your new source code. And basically you would have another image here which contains this layer and this layer, but this layer is different. So at the end you end up with two images, the old one, which could be your version 1, and then the second one that you just created, which could be your version 2. And that's how images are managed in Docker, version 1, version 2. We actually version images because we cannot modify an image, so we're constantly building new images, and then we need to remove the old ones and all of that. But no worries, I just want you to know that a layer in an image is read only. You cannot modify a layer. You could start from one layer and start doing things on top of that. And that means creating new images, right? So this is an image, your entire representation of your application in read-only. but remember that this is kind of a template, and with this template you can launch as many containers as you want. And there is something cool here, and that is that you can create containers which are gonna be running instances of your image. Basically, when you create a container, you add a new layer in here on top of the image, which is a read and write layer. And that means that you can modify the content of the image in the layer that was added. But wait, the content is not going to be impacted because the layer is a temporary layer, and the info that you need from here is going to be copied here by Docker automatically. So remember that the images are read only, but whenever you spin up a new container, you are basically creating a new layer, a read and write layer on top of the image, and then you can access all of the content of the image and you can modify it in the read and write layer. Once the container gets destroyed, I mean once the layer in here disappears, then the changes that you made are going to disappear as well. So please keep in mind that an image is read only, and you can spin up as many containers as you want using that image. And basically when you create a container, what happens is that you put a read and write layer on top of your image, and you can access the data from the image temporarily here. But once you delete the container, everything is gone, and the only one thing that is left is your image. So this is it for this video. I'll see you in the next lesson.